So now, as I said, the stability of the complexes is the degree of association of the complex in a solution, that is degree of the association of the ionic species present in your equilibrium. Now there is a term which is called equilibrium constant. Equilibrium constant is a value which refers to the magnitude of the stability of the complex. That is, higher the equilibrium constant, higher will be the stability of the complex, and higher will be the percentage of your complex in the solution. In case of determining the stability, the equilibrium constant is also known as the stability constant. For this reaction, that is M plus 4L gives Ml4. For this reaction, we can say that the overall stability constant of this is beta 4, and beta 4 is equal to Ml4, that is products divided by reactants, M into L raised to the power 4. So, products divided by reactants all raised to the power of the stoichiometric coefficients. However, this reaction is written as a test together. What if we break it into steps? What if instead of adding all of the 4 ligands at once, we add them one by one to the metal? So, let us see what will happen then. The overall stability constant of this is beta 4, okay, and beta 4 is equal to Ml4 divided by M into L to the power 4. This is the first step. For the first step, the equilibrium constant is K1 is equal to Ml divided by M into L. Then we go to the second step. For the second step, the K2 is equal to Ml2 divided by Ml into L. So, this is the equilibrium constant for your second step. For your third step, K3 is equal to Ml3 divided by Ml2 into L. This is the third step. And in the fourth step, all of the 4 ligands are now been added. So, K4 is equal to Ml4 divided by Ml3 into L. So, K1 was equal to Ml divided by M into L. K2 is equal to Ml2 divided by Ml into L. K3 is equal to Ml3 divided by Ml into L, and K4 is equal to Ml4 divided by Ml3 into L. Now, these K1, K2, K3 and K4, they are known as the stepwise stability constants, because they are the equilibrium constants for the stepwise reaction. So, they are the stepwise stability constant. So, what is the relation between your stepwise stability constant and your overall stability constant? Let us try to calculate or find the relation between your stepwise stability constant and the overall stability constant beta. So, if you remember, the overall stability constant for this reaction, that is M plus 4L gives Ml4, was beta 4, which was equal to Ml4 divided by M into L to the power 4. So, if I multiply K1 into K2 into K3 into K4, that is my stepwise stability constant, I will get Ml divided by M into L multiplied by Ml2 divided by M L into L multiplied by Ml3 divided by M L 2 into L multiplied by Ml4 divided by M L 3 into L. So, Ml3 cancelled out, Ml2 cancelled out, Ml cancels out. So, we get Ml4 upon M into L to the power 4. So, we can say that beta 4 is equal to K1 into K2 into K3 into K4. So similarly, we can say that beta n is equal to K1 into K2 into K3 and so on up to Kn. This is the relation between your stepwise stability constant and the overall stability constant.